Hey guys, welcome to Unit 11, Lesson 4. We are still working on related rates and triangle problems. We're going to be doing more of those right triangle problems. So pause the video and try the warm-up. The warm-up says, a 10-foot ladder is leaning against a vertical wall. So our ladder is 10 feet, which is already marked in the picture. The lower end of the ladder is being pulled away from the wall at a rate of 2 feet per second. So my dx dt is 2 feet per second, and it's going to be positive because when it's being pulled, do we agree that the distance, horizontal distance, is going to be increasing? So it's 2 feet per second. And then when the lower end of the ladder is 6 feet away from the wall, so I'm basically, this is my right triangle. I'm going to try sketch it here. So my lower end, this is 6 feet. So x is equal to 6. How fast is the ladder sliding down the wall? So I want to find dy dt, right? So I want to find dy dt because the wall is y. I don't know that. But I do know that I can find y using my Pythagorean theorem, which would be what? So x squared plus y squared equals z squared, right? And x is, if you know your Pythagorean triples, you should know that y is going to be 8. But let's quickly do this. 10 squared. This would be 100 minus 36, which is 64. So y is equal to 8. So y is 8. This is 8. I want to find dy dt. Also, the length of the ladder is not going to change. So my dz dt would be what? 0. So now I'm going to use my Pythagorean theorem, and I'm going to find a differential equation from that by taking the derivative on both sides. So 2x dx dt, remember we are differentiating with respect to time. So dy dt equals to dz dt. The 2's The 2's cancel out. Now what am I left with? I'm going to substitute in my x, which is what? 6 times 2 plus y is 8. 8 times, I don't know my dy dt, equals 0, right? Because z is what? 10 times 0 is 0. If I want to write that, 10 times 0 is 0. If I do the math, I get 8 dy dt equals negative 12. So dy dt is equal to negative 12 over 8, which is negative 3 over 2 feet per second. So I'm going to write that here. Negative 3 over 2 feet per second. So that is my answer. Part B. So it says how fast is the angle between the ground and the ladder changing. So this is something new that we are doing in this lesson. So it's asking us for how fast is the angle changing. So the rate of change of angle, or the derivative. Right? So this is my triangle. I'm just going to copy the picture that we drew. I know this is x, this is y, this is z. And that's my angle between the ground and the ladder. So this is my ladder, and that's the ground. So my angle, I'm going to call it theta. So now whenever we're looking for an angle, we will be using some kind of trig function. My best advice would be, you could use any right here, but my best advice would be to use something that has a z in it. Why? Because if you look above, the derivative of dz dt was 0. Not that the others would be wrong, but it would be easier for you to work with that. So I'm going to take cosine theta, which is the ratio for cosine is what? Adjacent over hypotenuse. So it's x over z. So I'm going to take the derivative of that, which is negative sine theta d theta dt. This is what we are looking for, d theta dt, because it's asking us how fast is the angle changing. Equals, here we're going to do the quotient rule. So it's going to be z squared in the denominator. Remember, your quotient rule is a prime b minus ab prime over b squared. So here it's gonna be dx dt times z minus x times dz dt, right? So now all I'm going to do is, on the right side, I know every single thing, but on the left side, how do I find sine theta? I know the ratio for sine theta is what? Opposite over hypotenuse. So what is my opposite? My opposite is 8 and my hypotenuse is 10. So can I not write, substitute with negative 8 over 10? D theta dt equals dx dt is 2, just substituting in. Z was 10, then we had up minus x6 times, that's 0 over 10 square. I can just solve this. D theta dt would be what? I have 1/5 left here, right? 1/5 times 10 over negative 10 over 8. I can do that. And if I simplify it, I am left with negative 1/4. This is angles. So angles are to be measured only in radians. So we're going to use radians per second. What does that mean? That your angle is decreasing at that rate every second. So part C, it says how fast is the area of the triangle formed by the ladder and the two walls changing. So I want to find the rate of change of the area of the triangle. So I'm going to use my triangle formula. It is base times height. Your base is your x and your height is your y. I'm going to use my product rule here. So dA dt would be equal to 1/2 dx dt y plus 1/2 x dy dt, right? If you're confused, it's a prime b plus ab prime. Now I know I want to find dA dt. All I'm going to do is substitute. Dx dt is 2 times y was 8 plus 1/2 x is 6 dy dt was, what was dy dt? It was negative 3/2. Yes, we found it in part 1. So the 2's cancel out and you're left with 8 and minus 9/2, right? So dA dt is 8 minus 9/2. And if you simplify it, it's 16 minus 9 is 7/2. Again, the units, it's the area, so feet square per second. So your dA dt is, so the area is increasing at this rate. Okay, let's do another question. It says a dinghy is pulled toward a dock by a rope from the bow through a ring on the dock 6 feet above the bow, which is already marked for you. The rope is hauled at 2 feet per second. So before I even go there, I'm going to mark this x, this is y, and this is z. So I know this is the rope, right? So the rate of change of rope, it's telling me what is, so dz dt is 2 feet per second. Do I know my y? I know my y is 6. And what else is given? It's saying how fast is the boat approaching the dock when 10 feet of rope are out. So basically it's saying my z is 10. I know my z is 10. I want to find how fast the boat is approaching. I want to find dx dt, right? I want to find the rate at which it's approaching the dock. So I already know this is 10 and y is 6. So can I not find x? X would be what? Using your Pythagorean theorem, it would be 8. We just did a very similar triangle. It's an 6, 8, 10 triangle. So I know my x is going to be 8. I want to find dx dt. That's what my question's asking me. What about dy dt? I don't know my dy dt. But think about it. Is this distance ever going to change? No, this is always going to be 6 feet. So my dy dt is 0. So now I am going to find my dx dt by using my Pythagorean theorem and taking the derivative of it. right? So this would be 2x dx dt plus 2y dy dt equals 2c dz. Oh, I don't know why I wrote c. I just want to do z, not c. This is z. So this is z. 2z dz dt. All right, again my 2's cancel out. And then all I need to do is substitute in what I know. I know my x is what? 8. Dx dt is, that's something I'm looking for. Plus y is 6, but I know dy dt is what? 0. And then z is 10 and dz dt is 2. Actually, it's going to be negative 2 because it's pulling away. I don't know if I did say that, but it is negative 2 because as you're pulling the rope, the distance between the rope and the hinge is going to reduce, so it's going to be negative. So now I'm going to solve this. This is what? Dx dt is equal to negative 20 over 8, which is negative 5 over 2. So dx dt is negative 5 over 2 feet per second. Part B. It's saying at what rate is the angle theta changing at this instant? So this is your angle. At what rate is it changing? Meaning I want to find d theta dt, right? Again, I would like to pick something that has already the derivative to be 0. So I would pick y over z, which trig function gives me y. That's adjacent over hypotenuse. So I'm going to say you can pick any. It would still work, but I'll just pick one where it's 0. So cosine theta equals y over z. So let's take the derivative. So it's negative sine theta equals, sine theta d theta dt equals, don't forget to write that, implicit is, again, you are doing your quotient rules, z squared, so it'll be dy dt z minus y times dz dt. How do I find the ratio for sine theta? What is the ratio for sine theta? It's opposite over hypotenuse. My opposite is 8. So this would be again negative 8 over 10, which is same thing as negative 4/5. I can write that. But I'm just going to keep it like that. And then I'm just going to use, I'm going to change color here so that we can dy over dt was what? 0. And z is 10 minus y is 6. dz dt was negative 2 over z square, which is 10 square, right? So what do I get? I get 12 over 100 d theta dt is 12 over 100 times, I can do negative 10 over 8. This cancels out. This is times 2. This is 3. And this is an extra 10. So I'm left with negative 3 over 20 radians per second. Okay, so that's basically it, guys. I want you to practice the remaining questions, and if you have any questions,